Alright, hello and welcome to Florida Man Math. This video is for students who'd like a review before taking an Algebra 1 Regents for Common Core, but you could also use it to prepare for any algebra test. The 24 problems I'll be showcasing are from Part 1 of the Algebra 1 Regents from June 2019. Each of the questions is multiple choice, where graphing calculators are allowed. I've linked PDFs of the full test and the answers down in the video description. You'll also find a link to the New York State's Office of State Assessment, which has all the Algebra 1 Regents exams and their solutions from June 2014 through January 2020, and that link stays updated for future exams as they're released. You can also find other subjects there too, such as geometry and Algebra 2 trigonometry. The best way to learn is by doing, and then learning from your mistakes. So you'll learn the most by pausing the video on each question as it pops up, and then trying to solve it yourself before I go into the solution. I've put timestamps in the video player, so you can skip to specific question numbers. After the last question, which is number 24, you'll see the answers all in one place in the video to check your work. Many problems can be solved in more than one way, and I'm always open to other ways on how to solve them, so please post your suggestions and identify any errors I've made in the comments below. If you like this type of content or learn something from it, please like this video and subscribe to get more videos like this. Thank you. Alright, this is a long video, so grab some paper, a calculator, and something to write with, and let's get started. Alright, let's get started with question number 1, which reads, the expression w to the fourth minus 36 is equivalent to, and then we've got a selection of different binomials involved. So probably the fastest way to do this would be to recognize that w to the 4 minus 36 is actually a difference of perfect squares. Specifically, it's the quantity w squared minus 6 squared. Now the reason why this is helpful is because if we remember our difference of perfect squares formula, which is a squared minus b squared equals a minus b times a plus b. Then all we have to do is just plug in what a and b are. So in this case, w squared takes on the role of a, and 6 takes on the role of b. So we get w squared minus 6 times w squared plus 6. Now because multiplication is commutative, we can swap this order around and compare that to the choices involved here. So it's got 6 on the edges, so we should look at choices 3 and 4. And we need the signs to be different. That looks like we've got choice 4. So the answer to question 1 is choice 4. So for question number 2, which reads, if f of x equals 4x plus 5, what is the value of f of negative 3? This one is pretty straightforward because all we have to do is plug in negative 3 wherever we see x inside f of x. So let's do f of negative 3 is equal to 4 times negative 3 plus 5. So now we just use PEMDAS to simplify. So 4 times negative 3 is negative 12. Adding 5. You could interpret this as the negative of 12 minus 5. If that helps, do it in your head. 12 minus 5 is 7, so we have negative of 7, which is just negative 7. So altogether for question 2, we have choice number 2 is the answer. Okay, so for question 3, which relation is not a function? And below our choices are an XY table, a graph, looks to be a linear equation here, and a mapping from 1, 2, and 3 to the letters A, B, and C. Now, this would be a lot easier if all 4 of the relations were, say, graphs. That way we could apply the vertical line test. And whichever one didn't pass the vertical line test, we could conclude that that's not a function. However, choice 4 prevents us from doing that because we can't really graph the relation 1, 2, 3 to A, B, C. In the same way we could plot a bunch of XY points from either of these other choices. So we need to use the more general definition of a function, which is that a function satisfies if a equals b, then f of a is equal to f of b. And what this is saying in plain English is that if you plug in the same input twice, then you're not going to get two different outputs. So once you plug in an input into a function, it'll produce that output associated with that input every single time. And the reason why this is important is because if we look at this relation, if you plug in 2, it maps sometimes to A and sometimes to B, and that's not allowed if this is going to be a function. So this does satisfy our answer, which is looking for the relation that's not a function. So for question 3, the answer is choice 4. All right, for number 4, we have given f of x is quantity x minus 2 squared plus 4, and g of x, which is quantity x minus 5 squared plus 4. When compared to the graph of f of x, the graph of g of x is, and then our 4 choices involve some sort of shifting, from shifting 3 units to the left, 3 units to the right, or shifting 5 units to the left, 5 units to the right. So it's shifting in some direction, side to side, left or right, and it's shifting some number of units, either 3 or 5. So if we can identify how much it's shifting by, then that eliminates half the choices. And if we can identify in which direction, that eliminates the other half of the choices. And so we should be left with the correct answer. So there's 2 ways you could do this. Probably the easiest way would be just plugging these 2 equations into your calculator and graphing them. And being a tool that you have available for this question, we can, looking at just kind of a sketch of the results here. So plugging in f of x, which is x minus 2, quantity squared, plus 4, I get this curve, approximately. And this is about 4-ish units up. And if I plug in g of x, which is quantity x minus 5 squared plus 4, then I get this curve. So it looks like it went 3 units to the right. Not quite 5, but definitely 3. So I'm inclined to pick 2. But let's check our answer algebraically to make sure this makes sense. What I notice about g of x is that we can write it like this, which is, instead of x minus 5 in the quantity, I'm going to write this. X minus 3 minus 2 squared plus 4. Now this is still technically g of x because all we did is just split up the minus 5 in a clever way. And the reason is because if I adjust this x as the input to counteract the x minus 3 here, the counteraction will be g of x plus 3 is equal to, this will just remain x, and then the minus 2 plus 4. And so what this means is this is f of x. So we have this relation. F of x is g of x plus 3. And there's that plus 3 in the positive or to the right direction. So that's why both algebraically and graphically for question number 4, we should pick answer number 2. So for question 5, students were asked to write 6x to the 5th plus 8x minus 3x cubed plus 7x to the 7th in standard form. Shown below are the 4 student responses. So we have 4 different polynomials here. They're all the same in terms of what characters they involve. It's just really the ordering of the powers of x. So the key here is to remember that standard form has to do with descending order. So you want your highest power first, counting down to your lowest power. So if we look at our original polynomial, we have our highest power is a degree of 7, and the next highest is 5, the next highest is 3, the next highest is technically 1. We just normally suppress this exponent 1 when it's a linear term. So we should be looking for 7x to the 7th to be our leading term. and it looks like Anne is the only one that has that choice. All the others you can see aren't in descending order, while Anne goes from 7 down to 5, down to 3, down to 1. So that makes the answer to question 5, choice number 1. So for number 6, we have the function f is shown in the table below. We've got a table of x values and f of x values. Which type of function best models the given data? And the choices are exponential growth, exponential decay, linear with positive rate of change, and linear with negative rate of change. So just looking at the outputs of this function, we might notice that these look to be powers of 3. So for example, 9 is 3 squared, and 27 is 3 cubed. And so going backwards, you could actually see 3 to the 1 is 3, and 3 to the 0 reduces to 1. So because these exponents match up with the x values in the rows of the table, it seems reasonable that f of x could just be straight up 3 to the x. And this defines an exponential function. So we can cross off choices 3 and 4. And now to decide whether this is exponential growth or exponential decay. And basically, the way you can tell is whether the base is greater than 1 or less than 1. If it's greater than 1, we get growth. And if it's less than 1, we get decay. So because 3 is greater than 1, we can pick, for question number 6, choice number 1, exponential growth. So for number 7, which expression results in a rational number? And we have several choices involving square roots. So before doing any of those, we should understand the definition of rational comes from the notion of ratio. That is, a rational number is a number that can be expressed in the form m divided by n, where m and n are integers. So an example of that would be 1/2, because 1 and 2 are integers. Another example might be 1/3. And another way to interpret a rational number is that it can also be written as a terminating decimal, such as 0.5, or it could be represented as a repeating decimal, such as 0.3 repeating. So the question is, which expression results in a rational number means that 3 of these numbers are irrational. So if we go through and compute, you could get away with plugging these into your calculator. And so if you plug in number 1, you get square root of 2 times 18, which is square root of 36, which is 6. And that, of course, is a rational number because you can write it as a ratio 6 to 1. And so we've actually found the answer right away. If you plug in the other answers, you'll find that you get decimals that are neither terminating nor repeating. And so for the answer to number 7 is choice number 1. So for number 8, we have a polynomial function is graphed below. Which function could represent this graph? And we've got a selection of various functions down here. So to be one of these functions, they need to have the same roots for sure. So let's take a look at the roots of our function here. We've got a root at -2, we've got a root at +1, and a root at +2. So that means that, just in order of increasing, we have a root at -2, a root at +1, and a root at +2. Now, any function that, once you've identified all its roots, you can express in the following way. You can express it as x minus the first root times x minus the next root times x minus the next root, and so on. This happens to have 3 roots, so we stop at root 3. And in general, there could be like some constant multiplied by this, but the important part is that the roots themselves are in this format. So if we were looking for an f of x, it would have to satisfy some constant times x minus r1, which is minus 2, times x minus r2, in this case r2 is 1, times x minus r3, in this case r3 is 2. And so once we clean this up a bit, we get some constant, possibly, times these minus signs cancel out, so we get x plus 2 times x minus 1 times x minus 2. And if we look at each of the choices down here, it looks like there's a term for involving the ones out front and then the other terms following after. So if we rearrange our target polynomial just based on the roots of this graph, it'll be some constant times x minus 1 times x plus 2 times x minus 2. Due to the commutativity of multiplication, you can swap the order of the factors here. And this looks really similar to the formula for difference of perfect squares. Namely, if you have x plus something and x minus something being multiplied, then you can go backwards from this formula, which reads a squared minus b squared is equal to a minus b times a plus b. So that leaves us with c times x minus 1 times, in this case the a value is x squared, and it's a difference of perfect squares, so we need the square of 2 squared. So just condensing that a little bit further, we get c times x minus 1 times x squared minus 4. And so in all of these cases, there's no other constant out front, so that means this c is actually equal to 1, so we can suppress writing it here. And then we're left with one of the choices, x minus 1 times x squared minus 4. So that means we can choose this. And for question number 8, we'll take choice number 3. Alright, so number 9. When solving p squared plus 5 equals 8p minus 7, Kate wrote p squared plus 12 equals 8p. The property she used is, and we have a choice between the associative property, commutative, distributive, and the addition property of equality. I think the best way to talk about this would just to be reviewing each of the properties, because the example problem could have tested any one of these, and you should know all 4. So we'll start off with associative, and basically you can kind of think of this as when you reorder parentheses for certain operations, such as, let's say you've got a plus b plus c. This agrees with our intuition that adding things in a different order doesn't change the final sum. So, for example, addition is associative because it follows this. Similarly, multiplication is also associative. So a times b times c is the same as a times b times c. So those correspond to associative. How about commutative? This one is even more intuitive in the sense that if you just swap the order of certain operations, like addition, then the sum also doesn't change. So a plus b equals b plus a is an example of how addition is commutative. It also works for multiplication. A times b is equal to b times a. So if you ever look at a multiplication table, your times tables, you'll see that they're symmetric about the diagonal. That's due to commutativity of multiplication. As for distributive, this one is basically just the motions of, let's say you're distributing a times b plus c, then distributive property means you distribute the operation of multiplication. So you get A times B plus A times C. And finally, we have the addition property of equality. And for this, I'm just going to use the example above, not just because by process of elimination it's the correct answer, but because it's a good demonstration. So you've got P squared plus 5 is equal to 8P minus 7. And we have P squared plus 12 equals 8P. So the only thing on this side is 8P, so we should get the 7 over. And due to the addition property of equality, we can just cancel out this 7 by adding it. But if you do something to one side, you have to do it to the other. That's all this property is about. So you get P squared plus 12 equals 8P. And that's exactly what happened here. So that's why for question number 9, we choose choice number 4. Question 10 reads, David wanted to go on an amusement park ride. A sign posted at the entrance read, "You must be greater than 42 inches tall and no more than 57 inches tall for this ride." Which inequality would model the height, x, required for this amusement park ride? And we've got various intervals here, involving some of them strictly less than, strictly greater than, or less than or equal to, greater than or equal to. And because the points of interest here are 42 and 57, for all the choices, that seems a natural place to start for creating our own interval to find the correct answer. Now, intuitively, the axis of height goes up and down, right? But there's no reason why we can't model it side to side to basically create our own number line. So let's do something like a point of interest is 42 inches here, with increasing height going to the right, just like a number line would. So now we need to look at the question again for specifics about which region is included. So you must be greater than 42 inches tall to ride this ride. So even if you're exactly 42, you still can't go. So that means this would be an open circle on the interval. And you can't be more than 57 to ride the ride. So that means you're allowed to be 57 inches tall, but not more than. And everything in between is allowed. So just connecting these, we have our interval. And again, there's an open endpoint on 42 and a closed endpoint on 57. So now we just need to create the inequality and the associated intervals here. So for 42, we have, this is open, so that means there's no or equal to. And because it's all of our allowed heights for riding the ride are greater than 42, you could say something like 42 is strictly less than x. On the other side of this interval, you're allowed to be 57, so you can be or equal to. But we want all the heights less than 57. So less than or equal to 57. And just merging these two characters in the same way, you get 42 less than x less than or equal to 57. So this means we can choose choice number 1 for question number 10. Okay, so for question number 11, which situation can be modeled by a linear function? And we've got population of bacteria tripling every day. The value of a cell phone depreciates at a rate of 3.5% each year. An amusement park allows 50 people to enter every 30 minutes. And a baseball tournament eliminates half of the teams after each round. So, because only one of these is a linear function, that means all the rest are not linear functions. So let's see if we can pick up on a pattern for comparing two of them and see if that extends to all the nonlinear, and by process of elimination we can find the linear one. So notice that for choice 1, the population of bacteria triples every day. So basically that means a common factor of, you get like a times 3 multiplier here. And if we look at number 4, a baseball tournament eliminates half of the teams after each round. If you're modeling the number of teams based on the current round, you could think of that as there's a times 1/2 multiplier. And so what we're looking for really is, if these two have a multiplier in common, then which one of these remaining situations is more like that? The value of a cell phone depreciating at a rate of 3.5% each year, or an amusement park allowing 50 people to enter every 30 minutes. So it looks like choice 2, depreciating at a rate of 0.35% each year, that's the same thing as multiplying by that percent less than 100. That is to say, if you have 100% minus 3.5%, that's the same thing as multiplying each year by 96.5%, which is still just a multiplier. So all these three choices, 1, 2, and 4, are multiplier based, and by process of elimination, that means the correct answer is choice 3. More directly would be to observe that if you were to plot choice 3, allowing an amusement park 50 people to enter every 30 minutes, then the graph would look something like, let's say this is time, and this is number of people. And if every tick mark measures off 30 minutes, then this will only go up by 50 each half hour. And so that would create a line. So that's why for number 11, choice number 3 is correct. Okay, for number 12, Jenna took a survey of her senior class to see whether they preferred pizza or burgers. The results are summarized in the table below. Of the people who preferred burgers, approximately what percentage were female? So what we should do is just be looking at the category of burgers and decide what equation to set up where we get the ratio of females preferring burger versus all people preferring burgers. So the ratio we're looking for is 26, because that's for this entry. And then we want to divide that by the sum of all people who preferred burgers. So just plugging and chugging, we have 26 divided by 42 plus 26, which is 68. And putting this in the calculator, I get a decimal of 0.38235 ... And so to convert this into a percentage, we just have to move the decimal place 2 places to the right. And so this could be 38.2 and other decimals percent. And so that means for question number 12, we take choice number 2. So question 13 reads, when 3a plus 7b is greater than 2a minus 8b, is solved for a. The result is, and then we have 4 choices for when a is on the left-hand side and b is on the right-hand side. So let's take our original equation, inequality, 3a plus 7b greater than 2a minus 8b. And we want to get all the a's to the left-hand side. So let's subtract this 2a because it's canceling out the positive 2a on the right. And if you do something one side, you have to do it to the other. So we have 3a minus 2a. That's just 1a, but we can suppress writing the 1. And then 7b is greater than negative 8b. And likewise, we want to get the b's to the right-hand side. So to undo plus 7b, the antidote is minus 7b. We cancel that out. Again, if you do something to one side, you have to do it to the other. So get minus 7b. So altogether, we're left with a is greater than we have negative 8b minus 7b. So you've got negative 8 of these objects, and you're taking away 7 more of them. So you could think of that in, if you're $8 in debt and you borrow 7 more, then you have a combined debt of 15. So the debt is indicated by negative, the total debt, and then the object that you're in debt with. So A greater than negative 15b. So altogether, that means for question 13, we want to pick choice number 4. So for number 14, the question reads, 3 functions are shown below. We've got A, which corresponds to the function g of x, which equals negative 3 halves x plus 4. Function B is f of x, equals quantity x plus 2 times quantity x plus 6. And then function C is this downward opening parabola, and its center looks to be at negative 3. It has roots at negative 4 and negative 2. So the question is, which statement is true? Choice 1 is that B and C have the same zeros. So that would mean that B and C cross the x-axis or touch the x-axis at the same point. In the case of B, we can set it equal to 0, and then because it's already factored, form a t-chart to find that x minus 2 would need, x plus 2 would need to equal 0, which implies that x equals negative 2 as a root. You could also set x plus 6 equal to 0 and get x equals minus 6 as a root. So this one checks out to match up with C, meaning there's a root at negative 2 here. There's also a root at negative 4, which doesn't match up here. So we can eliminate choice number 1. So A and B have the same y-intercept. Now A is a line, and it has a y-intercept of 4. If we were writing this in the form mx plus b, then the value of b is our y-intercept for A, which would go at the point 0, 4. But it doesn't really make sense to give a y-intercept to a parabola as directly, so we'll leave that possible for now. B has a minimum and C has a maximum. Well, C does have a maximum here, so that checks out. It also happens to be part of choice 4. B has a minimum. If we think about that, let's factor this, or distribute rather. We'll get x squared plus 6x plus 2x plus 12. And so collecting terms, get x squared plus 8x plus 12. And so if you could just put this in your calculator too, and then we can get some behavior based on the shape. So let's do plugging function B into the calculator. And the graph that I get is very roughly, it looks like something like this. So that would imply that B has a minimum, C has a maximum, so we're inclined to choose that. And given that we had some reservations about choice choice 2, we can eliminate that. And we can eliminate choice 4 because although C has a maximum here, A doesn't have a minimum because it's a line. So that doesn't make sense. So altogether, for question 14, the answer is choice 3. Alright, for question number 15, Nietzsche's sister is 7 years less than twice Nietzsche's age A. The sum of Nietzsche's age and her sister's age is 41. Which equation represents this relationship? So for this, we see each of the choices has the characters A, 7, 2A, and 41 floating around in various configurations. So we should go through and interpret what each of these statements mean. So for the first part, this says Nietzsche's age plus this quantity equal 41. So if this corresponds to her sister's age, then we'll be good. Now this says 7 minus 2a, so that would correspond to the first sentence. 7 years less than twice. That would read the other direction, though, which would say 2a minus 7. So if that were true, then a plus 2a minus 7 would equal 41, which actually happens to be choice 2. So we can go right away and observe that for number 15, answer number 2 is correct. So for question number 16, the population of a small town over 4 years is recorded in the chart below, where 2013 is represented by x equals 0, and population is rounded to the nearest person. So we have our population from 2013, 14, 15, and 16, and it looks to be growing each year. The population p of x for these years can be modeled by the function p of x equals a times b to the x, where b is rounded to the nearest thousandth. Which statements about this function are true? And then we have various choices for a and b, and we need to pick a pair of them. So it's really about eliminating one of the two choices from 1 or 2, and one of the two choices from 3 or 4. So any model that maps this population correctly needs to satisfy an initial condition. And the easiest way to check that, both conceptually and algebraically, is just to plug in 0. And in this case, if p of x is equal to a times b to the 0, where we're trying to determine a and b, p of x is a times b to the x, then p of 0 must be a times b to the 0. This number is just a times 1, so this is equal to a. And you can interpret this as the initial population. And that's actually what it means to be p of 0 here. Now, in the problem, it has 2013 is represented by x equals 0. So 2013, initial population of 3,810. So that implies altogether that a must be 3,810. So we've eliminated half the choices here by crossing off statement 2. So that means by extension, we can eliminate choices 3 and 4 because they include that statement as part of their combination. So now it's just a matter of determining which of these statements corresponds better to the value of b. We've got b is equal to 0.035 and b is equal to 1.035. Now, in the model, p of x equals a times b to the x. The b here represents b is equal to 1 plus r, where r is a number that indicates the rate of growth or decay. If r is positive, then it indicates growth. If it's negative, it indicates decay. So we just have to determine. We could also just look at the value of b. If the value of b is greater than 1, that's also growth. If the value of b is less than 1, that's decay. So in here, we see, because our population is growing, it makes more sense to take statement 4 as opposed to statement 3. So altogether, if we have statement 1 and statement 4, that means for question number 16, we have answer number 2. Alright, for question 17, when written in factored form, 4w squared minus 11w minus 3 is equivalent to, and then we've got 4 choices of binomials. So the surefire way to solve this would be to find the roots of this polynomial, 4w squared minus 11w minus 3, and then compare that to the roots of each of these factored versions. But that's rather tedious, and we can probably be slicker about it. So because they're already factored in basically the same way, we should check, is the leading coefficient the same? So if you have 2w times 2w using FOIL, just the first is a checking, we'd have 4w squared. That'll be true for this part. which matches up with this. However, choices 3 and 4 also produce 4w squared for FOIL, so that doesn't help us. What about the last part of FOIL, the L? If we do positive 1 times negative 3, that gives negative 3. Negative 1 times positive 3, same deal. And then basically copy-paste those results over here. So that also doesn't help us. So we're going to have to kind of bite the bullet and figure out what's our central term. And what that's going to be from is the outer and inner terms from FOIL. So outer, for the first part, is minus 6w. And then the inner is positive 2w. That has a net effect of negative 4w, but that doesn't match our negative 11 that we need in the original here. So it can't be choice 1. How about the middle one? Again, checking outer, we have positive 6. And the inner, because the coefficients are the same, it's just the signs changing, it becomes minus 2. So that becomes positive 4w, and of course that doesn't match up. So we cross off choice 2. So it's a 50-50 shot now. Let's check choice 3. The outer is minus 12w, and inner is plus 1. This looks promising because negative 12w plus 1 is negative 11w. And just to compare, the outer of the last choice would be positive 12w. The inner is minus 1w. So that gives us positive 11w. We, of course, want the one with the minus sign here. So that means for number 17, correct answer is choice 3. All right, for question 18, which ordered pair does not represent a point on the graph of y equals 3x squared minus x plus 7? So for each of these points, it looks like we start off with some multiple of a half involving 0.5 or possibly 0.25. And each of the choices end up with 0.25, 0.25, 0.25, 0.25. So there's really no immediate way to tell which one is the odd one out that can't be on this graph. So that means 3 of these 4 points are on this graph of this parabola here. So probably the best way to do this, honestly, would just be put it in a graph and find the value in an XY table. So plugging this in, calculator, we have y equals 3x squared minus x plus 7. And then pressing graph, I get a sketch looking like basically this, centered at the origin and going off into infinity in these directions. So it's concave up. And we want to press trace and then plug in each value for the input and compare that to the options for the output. So plug in negative 1.5. I get 15.25. So that means that choice 1 is on the graph, so we can eliminate it from contention here. How about 0.5? So pressing trace again, 0.5. I get the output of 7.25. So that matches up. So it is on the graph, therefore it's not the answer to this question. How about choice 3? So plug in 1.25. And I get 10.4375, which does not line up here. So by extension, that means it's the answer to our question. And so the answer to number 18 is choice 3. All right, for number 19, given the following 3 sequences, sequence 1 is 2, 4, 6, 8, 10, and so on. Sequence 2 is 2, 4, 8, 16, 32, and so on. Sequence 3 is A plus 2, A plus 4, A plus 6, A plus 8, and so on. The question is, which ones are arithmetic sequences? So each of these options involves 1 or 2 choices, or possibly all 3. So we should just kind of go through and check individually each one and then collect the results later. So recall that the definition of an arithmetic sequence is basically when you're adding a common difference between two terms. So basically, if you have any two terms, such as, let's say, a sub n, and you want to subtract the previous term, you're going to get a common difference of d. Another way to phrase this is that you can generate the next term by taking your previous term and adding the common difference. So as long as the difference between two consecutive terms remains constant, then that's one way to identify a arithmetic sequence. So let's check the common difference, if possible, of sequence 1. So the difference here would be 2, plus 2 again, plus 2, plus 2. And this looks to be, and so on. So I think that this one is arithmetic. So that means in terms of choices, if 1 is included, we can't have just 2 and 3 only. So we can eliminate choice number 3. So how about sequence 2? We have a difference of plus 2, plus 4, plus 8, plus 16. So this is clearly not a constant common difference. And you might also observe that these are also the powers of 2, which is an exponential function. So this would follow something like 2 to the x. So this is not arithmetic, therefore it can't be choice 2. So we can cross off any sequence involving choice 2. And by process of elimination, we've identified the correct answer. So just for completeness, let's check to make sure there's a common difference here. So the difference between a and a plus 2 is plus 2. The difference between a plus 2 and a plus 4 is plus 2. And that seems to continue. So that's why we can identify sequence 3 as arithmetic, and therefore the answer to number 19 is confirmed to be choice number 2. Okay, so for question 20, a grocery store sells packages of beef. The function C of W represents the cost in dollars of a package of beef weighing W pounds. The most appropriate domain for this function would be, we've got a choice between integers, rational numbers, positive integers, and positive rational numbers. So the first part of this question is the most appropriate domain for this function. And recall that the domain is the set of valid inputs for a function. So if C of W is the function, the input is, of course, W, which represents pounds, a package of beef weight W pounds. So W is measured in pounds. And the question is, what unit or what numbers would correspond to measuring something in pounds? So, for example, integers probably wouldn't make too much sense because you could have negative numbers, and we don't really have a notion of negative weight. So positive integers would be more appropriate than integers simply because of the word positive. So that means we can eliminate choice number 1. And same deal with rational numbers. The word positive for rational numbers, which are a ratio of integers, it makes more sense to talk about positive weight. So with that qualification, we can eliminate choices 1 and 2. So it's a 50-50 shot if we needed to guess between positive integers and positive rational numbers. Let's take a look again at positive integers. That means only the numbers 1, 2, 3, 4, and so on. It's very unlikely that every single package weighs exactly an integer number of pounds. Compare that to a rational number, so that could include things like positive 1.01 pounds or positive 2/3 pounds, which would have the decimal expansion 0.6666 and so on. And because these are fractions, you could measure half a pound or a quarter of a pound, third of a pound. That seems more appropriate for this function. So let's cross off choice 3, and by extension, the answer to number 20 is choice 4. So for number 21, The roots of x squared minus 5x minus 4 equals 0 are, and we have 4 choices of possible pairs of roots. So without bothering trying to factor this right away, we could always just use the quadratic formula, and that will work every single time. So we might as well show that here. So our coefficients for a, b, and c, when our polynomial is written as ax squared plus bx plus c, standardized to equal to 0, we just have to play the matching game for the coefficients. So a matches with the number in front of x squared, which is positive 1. B is the number in front of x, which is negative 5. And c matches up with the constant, which is negative 4. So recalling our quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we just need to plug and chug. So x is equal to negative of the value of b, being careful to put it entirely in parentheses so we don't get any minus signs lost. The value of b is negative 5, so we're going to negate that and get a double negative there. Similarly, placing negative 5 in parentheses for b here. That way we don't lose any or gain any minus signs accidentally. The minus 4 comes along for the ride, times a, which is positive 1, times c, which is again in parentheses to be careful about those minus signs. And then we divide everything by 2a, which is 2 times 1. So let's simplify this a bit. So negative of negative 5 is positive 5. And then negative 5 quantity squared is negative 5 times negative 5. Again, the minus signs cancel out, and the 5s are left with 5 squared, which is 25. Then we have minus 4 times 1, which would give us minus 4. And then we take that minus 4 times this minus 4, another cancellation, so it turns positive, and 4 times 4 is 16. And the denominator is just 2 times 1, which is 2. So we can collect everything by saying x is equal to 5 plus or minus the square root of 25 plus 16, off to the side here. 5 plus 6 is 11, carry the 1. 1 plus 2 plus 1 is 4, so we get 41 here. And everything divided by 2. This is promising because this corresponds exactly to, for question number 21, the answer is 2. 5 plus or minus square root of 41 all over 2. Alright, so for number 22, the following table shows the heights in inches of the players on the opening night roster of the 2015-2016 New York Knicks. And we've got several data values here. Looks to be just everything in the 70s and 80s. The population standard deviation of these data is approximately, and we've got 4 choices, 3.5, 13, 79.7, and 80. So we should begin by recalling what population standard deviation is, what its formula is, what it measures. And so this isn't on the reference sheet, but population standard deviation is given by sigma is equal to the square root of the average for n values of the sum from I equals 1 to n of the quantity x sub I minus, this is population, so we're using mu squared and everything under the square root. Okay, so let's explain this definition of computing population standard deviation given n inputs. Now, we'll start off by identifying that mu is the population mean, so that's the average. And then we've got 1 over n, where n is the number of data points involved, and each of these x sub i's is one of the data points. So we're taking the square root of 1 over n of the sum of the squared differences from each sample with respect to the population average. So that's the computation form of sigma, which is population standard deviation. You could also remember by root mean square. So you've got root, you've got something involving divide by the number of inputs. That's sort of like a mean, and then square here. But what does population standard deviation actually interpret? The best way is probably to think of it as like the average amount of deviation from the population mean. So if we compute the population mean, we've got add up all these numbers. 84 plus 80 plus 87, 75, 77, 79, 80, 74, 76, 80, 80, 82, 82. And that turns out to be the sum is 1036 over there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. So mu is population mean is equal to 1036 divided by 13. And I get 79.69 ... So basically this question is asking what is the average deviation from the population average of each of these data. So most of these data are, the lowest one here is 74 and the highest one is 87. So given that the population mean is about 80, most of these numbers are clustered very close to the population mean. So that suggests that sigma, population standard deviation, should be really low. It shouldn't be really high like these. So we can cross off that, and that, even though that number appears, that's a population mean, not population standard deviation. And then comparing these two, which one makes more sense to be the average distance of each of these numbers from about 80? So some of them are basically exactly 80 or 79. So given how clustered these data are, how narrowly dispersed they are, we should go with, for number 22, choice number 1. The alternative here is just to plug in each of these 13 data into your calculator and press like the stat button and look for the term sigma sub x, and that'll give you this number. The exact number I get is 3.49, and that rounds up. So that's an alternative way to do it if you just want to plug in directly. Alright, question number 23. A population of bacteria can be modeled by the function f of t equals 1000 times 0.98 raised to the t, where t represents the time since the population started decaying, and f of t represents the population of the remaining bacteria at time t. What is the rate of decay for this population? So I just like to take note that f of t has the form a times b to the t, where a is a constant and b is a base, and t, of course, is the input time. So let's kind of recall what it means for this base b. So when b is equal to 1, which rarely ever happens in any interesting situation, this is a constant population. Because it's pretty rare to have anything stay the same. If you have b is greater than 1, you have a growing population. And the other direction, when b is less than 1, you have a decaying population. So this is pretty much confirmed by the fact that b, in our case, is equal to 0.98. And now the secret to this is really just saying the amount less than 1 is the rate of decay. So, for example, we have 0.98, which is how far away from 1? Well, that's just 0.02. So this as a percent becomes, we have to shift the decimal point 2 places over, 2%. So that's why we can choose for number 23, choice number 2. For what it's worth, this works in the other direction too. The amount over 1 tells you the rate of growth. So let's say you have 1.12 as your value of b, then this is equal to 1 plus 0.12. This converted to a percent would be 12% growth. So the same mechanism works whether it's for growth or decay. You just have to make sure you convert to a percent instead of leaving it like a decimal and a percent at the same time. All right, question number 24. Bamboo plants can grow 91 centimeters per day. What is the approximate growth of the plant in inches per hour? So we've got our original growth rate of 91 centimeters per 1 day, right? And we want to convert this eventually into inches per hour. So the way to do that is basically creating a sequence of products that cancel out the units in the direction that we want. So for example, we need inches per hour, and right now we've got some length per day, so we should get rid of the days by canceling it out up top. So 1 day up here is worth 24 of our target unit, which is hours. Similarly, we need to cancel out centimeters to get inches. So we need to put centimeters down here and inches here. Now, if you look in the reference tables at the back of the Regents, it has the conversion between 1 inch is worth 2.54 centimeters. And this turns out to be enough information to solve everything. So let's cancel out our units that will cancel. So day cancels out with day, like we wanted. And centimeters cancels out with centimeters, also like we wanted. So the remaining units are inches divided by hours. So at the end of this, we have all of the numbers just multiply straight across. 91 times 1 times 1, all over 1 times 24 times 2.54. And now we just have to equip the units, which are the surviving units of inches divided by hours, inches per hour, which is the target. So now we just need to compute this. This is just a number. So using our calculator, we can have 91 divided by 1 times 24 times 2.54. I get 60.96. And again, the units come along for the ride. And then we just need to compute 91 divided by 60.96. And so plugging that in the calculator, I get 1.4927, and rounding it to the nearest, looks like our answer is in the hundredths, so we'll take rounding here, 1.49. So that corresponds to choice number 1. So question number 24 has answer number 1. We've reached the end of the questions on this part. As promised in the intro, here's a summary of the answers in one place to check your work. If you like this type of content or learned something from it, please like this video and subscribe to Florida Man Math to get more videos like it. If you're taking any sort of test, keep practicing, and I wish you good luck and good skill. And as always, thanks for watching.